day everyone, I am John Apolinar Macabare and I am going to discuss our culminating activity in Statistical Analysis 2, and my group mates are Ritson Ronchi Acosar and Samantha Padulya. So there are two objectives in activity. First is to determine the relationship between one independent variable to two or more dependent variables. Second is to be able to apply simple and multiple linear regressions in real-life scenarios. So in our culminating activity, we choose to study the analysis of the relationship between commute distance and transportation cost using simple linear regression. So I have here a scenario. 20 university students from Eastern Visayas State University main campus were surveyed through Google Form on May 15, 2026 about the distance they travel from their home or boarding house to the campus in kilometers X, and the transportation cost is Y that they allocate from their allowance daily. Commute distance will serve as the independent variable Y, in which we determine if it affects the transportation cost as the dependent variable X. So in table 1, this is the commute distance and daily transportation cost of the 20 university students. So we have the commute distance in kilometers, which is the variable Y, and transportation cost, which is the variable Y. So this is the 20 students that we surveyed through Google Form on May 15, 2026. So table 1 presents the transportation cost incurred by university students based on the distance they travel from their home or boarding house to school campus. The transportation cost serves as the variable X or dependent variable because it varies according to the distance traveled by the students, which is measured in kilometers. As the travel distance increases, the transportation expenses of the students also tend to increase due to higher fare rates and additional transportation charges. The data in the table aims to determine the relationship between distance traveled and transportation costs among university students. It also helps identify how travel distance affects the daily expenses of students, especially those who live farther away from the university. Through this information, the researchers can analyze patterns in transportation spending and understand the financial impact of commuting on students' academic life and budgeting. So in table 2, this is the computation values of the table 1. So we have here, let me count this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 computation values. So in table 2 presents the computation of values used to determine the relationship between transportation costs and travel distance among university students. The table shows the deviations of each value from their respective means, represented by xi minus x bar and yi minus y bar. It also includes the product of these deviations, xi minus x bar times yi minus y bar, and the squared deviations of the x values, xi minus x bar squared. These computations are important in solving for correlation and regression analysis, which are used to measure the strength and direction of the relationship between two variables. The table helps determine whether transportation cost increases or decreases as the travel distance changes. Positive and negative values in the computed products indicate how the variables move in relation to one another. The total values at the bottom of the table summarizes the overall variation and relationship of the data gathered from the respondents. Through these computations, researchers can analyze trends in transportation expenses and better understand how commuting distance affect the daily financial burden of university students. So this is the simple linear regression equation. BO is equals to summation of xi minus x bar times yi minus y bar over summation of xi minus x bar squared. So we already multiplied the equation, so we got the answer of 1084.8 over 162.95. So we will going to divide that, so we got the answer 6.657256827. We have to get the B1 formula, the B1 equation. So by getting the B1 equation, we have to use the formula y bar minus BO times x bar is equals to B1. So we already get the numbers, the formula, so we already have the answer. So B1 is equals to 57.8, and we are going to get the y hat answer. By getting the y hat answer, we have to minus the B1 minus the BO B0 and multiply it by 4.45. So the answer is 28.175. So the y hat is equals to 6.65725 plus 28.175 x1. So that is the simple linear regression equation. The scatter plot presents the relationship between transportation cost and distance traveled using a simple linear regression model. Each dot represents an observed data point showing how transportation cost varies with the distance traveled. The dotted regression line slopes upward, indicating a positive correlation between the two variables. This suggests that higher transportation costs are generally associated with longer distance traveled. However, the points are not perfectly aligned along the line, which means the relationship is only moderately strong and other factors may also affect the distance traveled. The regression equation is y is equals to 6.65725 plus 28.175 x1 indicates that for every additional unit increase in transportation cost, the predicted distance traveled increases by about 6.66 units. The constant value 28.175 represents the estimated distance traveled when transportation cost is 0. The coefficient of determination r squared is equals to 0.3349, shows that about 33.49% of the variation in distance traveled is explained by transportation cost. This means transportation cost has a noticeable influence on distance traveled, but there are still other variables that may contribute to the remaining 66.51% of the variation. So let's proceed to recommendations. Based on the results of the study and the model's weak predictive power, several improvements are recommended to enhance the accuracy of the analysis and improve resource allocation strategies. These recommendations may help identify the factors affecting transportation costs more effectively and support better decision making. So first is investigate high-cost anomalies. It is recommended to further examine transportation routes that shows unusually high cost despite having relatively short travel distances. These anomalies may indicate the presence of hidden factors such as traffic congestion, fare inconsistencies, inefficient route selection, additional transfer fees, or varying transportation rates. Conducting a deeper investigation of these routes may help identify the root cause of unnecessary expenses and provide opportunities for cost reduction. So second is analyze students using similar transportation routes. Further studies next is analyze students using similar transportation routes. Further studies should group and analyze students who use the same type of public transportation and travel along similar routes. Compare their transportation expenses, travel frequency, and distance traveled may reveal patterns or inconsistencies that are not visible in the overall data set. This approach can improve the understanding of how route similarities and transportation choices affect overall transportation costs. Third is the incorporate additional variables in the analysis. The study should include more variables that may influence transportation expenses to improve the predictive capability of the model. Factors such as fuel prices, road and route conditions, vehicle inefficiency, traffic levels, weather conditions, transportation availability, and travel time should be considered. Including multiple variables can improve a more comprehensive analysis and produce more accurate, reliable results. So last is implement route optimization strategies or software. It is also recommended to use route optimization tools or software to minimize unnecessary spending, especially on shorter trips with unexpected high transportation costs. These systems can help identify more efficient travel routes, reduce travel time, lower fuel consumption, and improve overall cost efficiency. Applying optimization strategies may lead to better resource management and more practical transportation planning. So that's it from my part. Thank you.
Okay, for the activity 2, this involves multiple linear regression wherein in a certain scenario, we are going to identify one dependent variable and determine its relationship into 2 or 3 or more independent variables. So here we have a scenario wherein we surveyed 20 students from Eastern Visayas State University main campus through Google Form on May 15, 2026. So they were asked for information on their total daily expenses, why, transportation costs, food expenses, and academic expenses. So this is to determine if there is a relationship between one dependent variable and 3 independent variables. So the total daily expenses will serve as our dependent variable y to determine how much the change in each 3 independent variable x affects y. So for the next slide, we have here the raw data that we obtained through Google Forms survey. So we have 20 students na survey, our n is equal to 20. Tapos natin y, which is the total daily expenses of each student. Our x sub 1, x sub 2, and x sub 3. X sub 1 is our transportation cost, x sub 2 is our food expenses, and x sub 3 is our academic expenses. So, nakuha natin ang values from those 20 students in a survey. Then, compute natin ang sum. next slide is the Microsoft Excel computation. So to lead us to a multiple linear regression, we are going to compute these values from x sub 1 times y, x sub 2 times y, x sub 3 times y, x sub 1 times x sub 2, x sub 3 and x sub 1 times x sub 3, x sub 2 times x sub 3, x sub 1 squared, x sub 2 squared, and x sub 3 squared. So through Microsoft Excel, compute natin ang error values. So mas napadali, and mas accurate pa. So no room for error na if magamit na yung Microsoft Excel. So with help of the computation Excel, nakuha natin yung error values in a short period of time. Tapos yung total natin, which is ini nga naka-highlight yung yellow. So with that, for the next slide, we have here the formula wherein yung if masubstitute natin ang error values hini based sa atong table, other slide, is makakuha natin yung determinant. The determinant is important para makuha natin ang variables multiple linear regression equation. So with this formula, substitute niya kaniya values. So again, Microsoft Excel, nakuha natin ang determinant in each matrix. So this is matrix. So that A1, so this is the value, that A2, that A3, and that A4. Okay, so for the next slide, we have obtained now our beta sub 0, beta sub 1, beta sub 2, beta sub 3. So beta sub 0 is that A1 over that A, that B sub 1, beta sub 1 is that A2 over that A, beta sub 2 is that A3 over that A, and beta sub 3 is that A4 over that A. So substitute lang natin ang values tira na nakuha natin ating previous slide. So may nakuha natin yung beta sub 0 is 83.88306238. Beta sub 1 is negative 0.05917124. Beta sub 2 is 1.010957114. Beta sub 3 is 0.7461234234. So pag i-substitute tayo ni multiple linear regression equation yung formula, makakakuha kitahin multiple linear regression equation which is now a y hat is equals to 83.8831 minus 0.0592x sub 1 plus 1.0109x sub 2 plus 0.7461x sub 3. So to confirm, mayroon natin the summary output. Naging compute gihap natin using Microsoft Excel. Makikita natin din natin mga coefficients, ang natin R squared, ang natin standard error, based observation, sa 20 observations ay. So makakuha natin yung coefficients, hini, natin x sub 1, x sub 2, x sub 3, in which we will notice nga same here, variables ni, nga nakuha natin, multiple linear regression equation. So that confirms nga our computation is correct. So next slide is a graph of a scatter plot model for multiple linear regression. This involves our 3x independent variable and its relationship at an y variable, which is the daily student expenses. So here we are. Our blue corresponds to our x sub 1. Our orange trend line corresponds to our x sub 2, and our gray trend line corresponds our x sub 3. So this graph visualizes the individual relationship between our three independent variables and dependent variable. So the obtained slope, which is the number before x, ini niya. Ini yung aton first nga what do you call this? first term, shows how much y changes for every 1 unit ni x. So all three independent variables have positive slopes, meaning a cost increase, daily expenses also increases. So the coefficient of determination nga na-obtain, or the r squared nga naka-indicate below at an equation, shows the percentage of variance in daily expenses explained by that specific variable. So next slide is also a graph that shows the relationship between our dependent variable y and our first independent variable, or x sub 1, which is the transportation cost. So this graph visualizes how our x sub 1 transportation cost affects total daily expenses. So it demonstrates that for every additional peso spent on transportation, the total daily expenses is nag-increase by 0.3736. On the other hand, since an r squared is very low, which is 0.151 or 15% or 15.1%, the transportation cost is a weak predictor overall daily spending. So in this case, we can conclude that most gutay lang percent total daily expenses are not cover the transportation cost. So we therefore conclude that transportation cost is a weak predictor. Next is the graph naman for our total daily expenses and the food expenses, x sub 2. So this shows the relationship between our dependent variable y and our x sub 2, or our dependent variable number 2. So this graph shows how the food expenses affects our total daily expenses. So this demonstrates that for every additional peso spent on food, the total daily expenses is na increased by 0.4344% or 43.44%. So we therefore conclude nga since r squared is 0.6671 or 66.71%, we therefore conclude that the food expenses is a strong predictor, meaning it has a strong relationship between our dependent variable y. Next is a table for our dependent variable y, the total daily expenses, and our x sub 3, our academic expenses. So this shows the relationship between the two. So this graph shows the steepest impact among the three independent variables. Why? Because it has the highest. It has 0.634. It shows that for every 1 unit increase in academic cost, the total expenses na jump in 0.622 or 62.2%. So like the food expenses nga ginpakita aton other figure, which is our figure 4, the academic expenses is also a strong predictor with 66.34% variance of total daily expenses. Next, so with that being said, the analysis between the dependent variable y, our total daily expenses, and the three dependent variable x, the transportation cost, food expenses, academic expenses, contains the concrete statistical results needed to determine significance. The most important variable based on the result was the food expenses, as it has the highest individual coefficient of determination, or r squared, of 0.6671. So this means that the food cost alone accounts for 66.71% of the total daily expenses. Therefore, food expenses is highly predictable and has a strong relationship aton dependent variable y. So on the other hand, academic expenses spending is very close with an R squared of 0.6643. And actually it's a steeper impact per unit, meaning it causes sharper spikes in total spending when it occurs. So the transportation cost naman has a very low coefficient of determination with 0.151 or only 15.1% of the variance to total daily expenses. The data points are highly scattered, indicating that transportation is statistically weak and statistically insignificant predictor of overall daily spending. So for the recommendation, we have several recommendations based on statistical weights of the variables. So first is, do not waste effort trying to heavily optimize transit routes or minor travel costs to save money, because it is statistically significant. Changing transportation habits will have almost no noticeable impact on your overall daily budget. So the allocated number 2 is allocate a fixed monthly reserve fund for academics rather than paying them out of regular daily pocket money. Third is to reallocate financial resources away from loose daily cash funds and them toward a fixed strict allowance system. So that is all for my presentation for activity 2.
And moving on to our activity 3, we conducted a study entitled a demand forecasting and decision making using multiple linear regression, forecasting daily customer demand in Dada store using multiple linear regression. For our scenario, 20 days of operational data were gathered from Dada store through direct observation and daily recording from April 26, 2026 to May 15, 2026. The study focused on identifying factors that may affect the number of customers visiting the store each day. So our independent variable used in the study were operating hours or X sub 1, number of displayed products or X sub 2, the nearby competing stores or X sub 3, and meanwhile our dependent variable or y represent the daily customer counts. So, and for our next slide, so this table represents the raw operational data gathered during the 20-day observation period. So as we can notice, the customer demand varies across different days. Higher customer counts were mostly observed during Sundays, such as April 26, May 3, and May 10. The increased were associated with higher product availability or displayed and fewer nearby competing stores that are open. And the next slide is our R computed value. So it was computed using Microsoft Excel. So the computation include x1 squared, x2 squared, x3 squared, x1 times x2, x1 times x3, x2 times x3, x1 times y, x2 times y, x3 times y, and then the total of each elements. So this is important in computing the regression equation or the multiple linear regression equation. And for our next slide, the constructed multiple linear regression, I just get it using the summary output. For this part, I would like to clarify that I did not manually solve the multiple linear regression equation because the manual solution was already discussed earlier by my groupmate. Instead, again, I used Microsoft Excel to generate the summary output and automatically obtain the regression coefficient that get our multiple linear regression, which is y hat is equals to 29.7653 minus 1.5465 x sub 1 plus 0.3272 x sub 2 minus 5.4930 x sub 3. And moving on to our scatter plot. So this plot operates the relationship between operating hours and the customer demand. So the regression line show a slight negative slope. It may indicate that the operating hours tend to slightly decrease customer demand by around 1.55 customer per additional hour, or 2 customers. However, the data points are highly dispersed and do not closely follow the trend line. So therefore, operating hours are not really considered a strong predictor of customer turnout in the die store. So the next scatter plot present the relationship between the product display and the customer demand. So the coefficient value of 0.3272 suggests that every additional display increases the expected customer count by approximately 0.33 customers. And then compared to operating hours, the data points here are relatively more aligned with the trend line, suggesting more stable relationship. And for our last scatter plot, it shows the relationship between the nearby competing stores that are open and then the customer's demand. So among all the variables, this figure demonstrates the strongest linear relationship. So the downward trend line indicates that as the number of nearby competitors increases, customer demand significantly decreases. The coefficient of negative 5.4930 means that each additional nearby store reduces the expected customer count by approximately 5 customers. The low p-value of 0.0011 confirms that this variable is statistically significant and is the most influential operational factor identified in our study. Moving on to our forecast feature values. To demonstrate the predictive capability of the constructed regression model, a forecasting simulation was conducted using a projected operational scenario for the die store. The store management aimed to minimize operating hours to reduce utility-related expenses while maintaining high product availability to attract customers under an average competitive environment. So the projected operational conditions were 12 hours operation, or the X sub 1 the displayed products X sub 2 and the 3 nearby operating competitor stores that are open or X sub 3. So these projected values were substituted into the regression equation. So it becomes y hat is equals to 29.7653 minus 1.5465 times 12 plus 0.3272 times 115 minus 5.4930 times 3, and we get the value of 29.7653 minus 18.558 plus 37.628 minus 16.479, and we get the 32.3563 or approximately 33 customer per day. And for our actual and forecasted customer, so this table compares the actual customer demand and forecasted customer demand across 20 days observation. The table also includes the absolute error values, which measure the difference between the actual and predicted customer counts for each day. So using these errors, the mean absolute error or the MAE was computed. So the model obtained, or we get the MAE approximately 2.92 customers. So this means that the regression model deviates from the actual customer count by only 3 customers on average. Considering that the observed customer demand ranges from 17 to 41 customer, this level of error is relatively low and acceptable for localized retail forecasting model. And for our comparison graph, this visually compares the actual and the predicted customer demand over the 20-day observation period. The close alignment between the two lines indicates that the model was able to closely track the actual customer traffic pattern with only minor deviation. Most forecasted values remain near the actual observation, which support the low MAE obtained earlier. So this visual consistency further validates the reliability and predictive of the multiple linear regression model. So in conclusion, this study successfully applied the multiple linear regression analysis to examine the forecast, the daily customer demand at the store using 3 operational variables, the operating hours, number of product displayed, and the nearby competitor density. The constructed regression model produced an R-squared value of 0.6345, indicating that approximately 63.45% of the variation in customer demand can be explained by the selected variables. Furthermore, the model achieved a mean absolute error or the MAE of 2.92 or approximately 3 customers per day, demonstrating acceptable forecasting accuracy for the short-term operational planning. And for our recommendation, based on our findings of the study, since the number of displayed product or the X sub 2 shows a positive relationship with customer demand, the store should maintain sufficient product availability, especially during high demand periods such as Sundays. Proper inventory organization and consistent shelf replenishment may help improve product visibility and attract more customer, priority should also be given to frequently purchased items to reduce stock shortage and improve customer satisfaction. So the second one, the store should also avoid unnecessarily extending operation hours, because the statistical analysis show that the longer operating hours do not really significantly increase the customer demand. And lastly, the store should develop strategies to minimize the impact of nearby competitors, such as improving product variety, maintaining stock availability, and offering unique or convenient products that are not commonly available in nearby stores. And that's all for our presentation.